Alright, so week 10 we're going to be going over monitoring and troubleshooting in Windows Server. So we're going to be going through and looking at all the different tools that you can use to monitor, and then all the different tools that you can use to troubleshoot Windows. A lot of this goes for other operating systems, just in a different format, but I'll go over some of those key differences as we get to them. So our learning objectives are going to be, we're going to outline the process used to monitor and troubleshoot systems, use common monitoring and troubleshooting tools, and then troubleshoot common hardware, software, operating system, performance, and network problems. So here's kind of what they go over as the monitoring and troubleshooting methodology. So you have your installation, then you have your configuration, security, and documentation, and then you have your ongoing monitoring, proactive maintenance, and then in between there you have your reactive maintenance. So monitoring happens all the time, proactive maintenance happens all the time, and then you have your reactive maintenance based on what happens during the monitoring. So example here is you monitor drive space all the time. You get an alert that you only got 2% left, so you increase the space before it runs out of space. That would be proactive maintenance. And then other example would be, you have it monitoring, but it fills up so fast that it doesn't actually alert you. That would be reactive maintenance, when you have to expand the volume when it, obviously is not working or runs out of space completely. So monitoring is the most time-consuming task. So you examine network connectivity, view log files, run performance utilities to identify problems and their causes. Proactive maintenance minimizes the chance of future problems. So you perform regular system backups, monitor available storage, create baselines, and analyze the performance trends. And then it's important that you document those for future reference, so you can go back and look at it. And then you have your reactive maintenance, corrects problems during monitoring. So like I said, you monitor systems, you find a problem, you fix it. That's your reactive maintenance. And then troubleshooting procedure efficiently solves a problem systematically. So steps to take when a problem occurs. You guys may have seen this before, but first thing, you gather information about it. So a lot of times that includes Googling, because you can't know everything about everything. So a lot of times you get the error and then you go straight to Google, search it, find what the problem could be. Then you isolate the problem. So you isolate the problem, and then you generate a list of possible causes and solutions. A lot of times there's only one possible solution, but the causes could be many. And then you implement and test possible solutions for results until the problem is resolved. So that's the part where you actually fix it, and then you document the solution and take proactive maintenance measures, like monitoring. If it's a service related issue, you monitor that service, things like that, so that you know when things have gone awry. And then 2 golden rules of any troubleshooting process: prioritize problems and try to solve the root of the problem. So, obviously if a space is filling up on a drive, generally that's not going to be that's not going to be the actual problem. It's going to be some kind of system that is doing something, that's sucking up a lot of data or writing log files, or something like that. So you always want to find the root of the problem. So here's another little flow chart on how that troubleshooting process works. So you collect your information, you isolate the problem, you list the possible causes and solutions, and then you have your test solution. If it failed, then you check another one, and then if it's successful, then you document that solution. So monitoring troubleshooting tools in Windows. So we have Server Manager and the Windows Admin Center. So these are used to monitor system events and performance. We did look at the Windows Admin Center briefly earlier this term. There's a lot of good information in there that you can get about a lot of different things. And then there's additional tools in Windows Server. You have Task Manager, Resource Monitor, Performance Monitor, Data Collector Sets, Event Viewer, and Reliability Monitor. So Task Manager, so you guys have probably seen Task Manager before. You can view and manage processes and quickly analyze system performance. Gives you a list of all the running processes, how much memory they're using, all that kind of stuff. And then the default display is a short list of processes started by the current user. And then you can click more details to get all of the user processes or system processes. And then there's also a performance tab that shows you CPU hardware utilization, number of processes, number of threads, number of handles, a whole bunch of different information on there. So Task Manager is a good place to start. And here's what that performance tab looks like. You get your CPU, you get your memory, you get how the Ethernet is working, and then you get all the details here on the right side. So selecting memory displays memory utilization information. So one thing to note is that committed memory is virtual memory from the paging file. Cache memory used to speed system file system access. Paged pool memory can be transferred to the paging file, and then non-paged pool memory cannot be transferred. So here's kind of where your memory looks, and you can see what that looks like. Then you have your Ethernet, which displays network statistics. High sustained send and receive values may indicate a DDoS attack. It's just one way to figure that out. High processor or memory utilization values, too many processes running on the system. You can have rogue processes that have encountered an error, and then it forces it to use an unusually large amount of processor time or memory. And then you got the same thing with memory leaks, processes continuing to use more memory until memory is exhausted. One system that actually does this by design is SQL Server. So you always want to make sure that your SQL Server is capped at a certain size of memory, so that you leave enough for the host operating system to do that. So here you can kind of see the Ethernet. So how do you identify rogue processes? So you sort processes by processor utilization and examine the results. For memory, it's very similar. You sort by memory utilization and examine the results. To end a process, you just right click and click End Process. And then you can view a list of processes organized by the user that started them by going to the Users tab. So here you can see all the processes, and you can see you can sort at the top. And then some of them have sub-processes, so you can look at those as well. See here that if you go to Users, under Administrator, it shows you all the processes started as Administrator. And then if there's other people logged in, it would do that. Same thing with System. So you can view more information for each process on the system by going to the Details tab. So that'll give you the process ID, status, username, CPU, and memory utilization. And then you can obtain additional information by right-clicking the process. That's the easiest way to look at it. And then problems related to unresponsive services. So this is resolved by restarting the service or starting if it is stopped. So you highlight the Services tab to view the services on the system, and then you can right-click and restart it. You can optionally go into the Services Windows Administrative tool to do the same thing, but you can also do it from Task Manager. So here is a look at the Details tab that shows you a little bit more. I like looking at this the most. It's just easier because you can see all the processes that are running. And then here's all the services under the Services tab. So you can right-click here, restart. You You can see whether it's running or not, what the process ID is, and then correlate that back to the details for troubleshooting. So resource monitor, to be honest with you, I don't use this too often in troubleshooting, but we'll go through it here. So this displays a graph showing CPU, disk, network, and memory utilization. And then it provides a list of selectable processes, displays associated detailed storage, network, and memory information. And then you have additional tabs where you got CPU, memory, disk, and network. These tabs display related services. So it's the CPU displays related services and file handles. Memory displays the physical and virtual memory. Disk displays the disks and files used, and the network displays the network activity, TCP connections, and ports. And we'll see that here. This is a good way to look at it. You can see it's just another way to use another tool to try to troubleshoot in Windows. I find that most times you can get most of the same information out of Task Manager. So Performance Monitor, most comprehensive tool for collecting data on real-time system performance. So this will actually track individual system resource use and then tracks how resources are behaving under the current workload. The performance information composed of 3 components. You have performance objects, performance counters, and instances. So many different performance objects and counters exist. So you can see here, this gives you a baseline view of everything, but you can monitor a lot of different things in Performance Monitor on a Windows system. So here's some of the common performance objects that you can use: a processor, memory, physical disk, logical disk, network interface. And then to add a performance counter, you just click the add icon, and then add counters window opens. You select the appropriate performance counters and instances, and then you can optionally show the description to view exactly what it's going to do. But here's what the add counters looks like. So you can see you have your available counters and then your added counters on the right. So you can also change the output view. So you can change the graph type to a histogram bar to view the performance counter as a bar chart, or you can do a report to view a report. So the report creates an appropriate simple performance baseline, and then you can save the report as a web page essentially. So here's kind of what the performance report looks like. So it's just not in a graph view. So one of the best ways to find issues on a Windows system is Event Viewer. This is normally, aside from Task Manager, depending on what the type of problem is, you're usually going to go to the event log first to try to find what the issue is. So you troubleshoot problems affecting a particular system component, service, or application in the event log. Or Event Viewer. Event Viewer tool used to view the event logs and events they contain. And then there's 5 standard Windows event logs. So you have application, security, setup, system, and then forwarded events. Forwarded events log stores events obtained from computers on the network using an event subscription. So we're not going to go too much into that, but that's another thing you can do. So here's what the event log looks like, or Event Viewer looks like. So you can see on the left, you have your custom views. So you can see that it's by server role, which is nice. So if you're looking at a particular issue with a particular service, if you click one of these server roles views, it'll give you all the events related to that particular role. And then you have your Windows logs, and then you have your application and services logs. And it's important to note that these views actually are a subset of the events down here. So you're just creating a view of particular events for a particular type of event. So you can also limit the number of events recorded in application and system logs. So Windows creates additional event logs located in Applications and Services Logs folder. And then viewing events, there's 6 different event levels that indicate the type or severity. So you have information, warning, critical, or error, critical, audit success, and audit failure. A lot of times, the only times you'll see audit success and audit failure is if you're in a security log area. Generally, will not see that under normal Windows logs. So filtering events. So you can limit the events that are shown by a number of different ways, but you open Event Viewer, select the log, and then click Filter Current Log in the Actions pane, and then you specify the criteria. So say you only wanted to see everything in the last 2 days, you would filter it by that. And then, as I said earlier with the views, you can create custom views. So for reoccurring problems, or to display events from multiple event logs, you can save a custom view for future use, and they're saved under the custom views folder that we looked at earlier. And then how you create a custom view is you click Create Custom View from the Actions pane, select the criteria, click OK, specify a name and location, and then you click OK. And then you select a custom view in the Event Viewer navigation pane displayed to show those events. And here's what creating a custom view looks like. So you can see here, you pick your type of event level, and then you can say any, when was it logged, the event logs that you want to look at. So how do we resolve common problems in Windows Server in 2019? So we have hardware related, performance related, software related, operating system related, and network related problems that are in general to Server 2019. So type of hardware related problems. So you have hardware component failures. So you have entirely or intermittently. So a lot of times when you have memory chips that are going out, you'll have intermittent problems. Then you have jabbering, which is intermittent malfunction causing hardware component to send large amounts of information to the processor when not in use. So this will slow down a processor and the rest of the Windows system. You detect by looking in the hardware events log, and then you look in other event logs for components, services, and applications that cannot reach the device. So another common hardware component to fail is a hard disk and solid state drive. So if you have fault tolerant storage configuration, RAID can regenerate the data. If it's not fault tolerant storage, you would have to restore the original data from backup. If the failed storage device contains the system or boot partition, then you have to use a full backup of the operating system. If not, then you can, if there is no full backup of the operating system available, then you would have to rebuild the system. So performance related problems. So this occurs when the system software requires more hardware resources than currently available. 2 resolutions: reduce the amount of software running on a system, add additional hardware resources. To minimize the change of performance problems, remove or disable any unnecessary services, and then adjust the number of processes competing for hardware resources. So here you can see, here's a service that we're going to disable because it's not used. Performance problems can also be remedied by altering the hardware. So you can either upgrade or add another processor, use bus mastering where devices can perform processing tasks normally performed by the processor. Don't know about that one. Never heard of that before. Add physical memory to the computer. Obviously, this can give more processes more working space in memory and reduce the use of the paging file. And then replace slower hard disks with faster SSD drives. So that's a common one. You have an older server that has spinning disks on it. Upgrading it to SSDs will indeed make it a lot faster. Same thing with a desktop computer. So software related problems, reasons for process failure during execution, missing dependencies, incorrect configuration settings, software bugs, conflicting applications. There could be restrictive file permissions, incorrect file ownership, missing environment variables, and that could prevent a process from accessing necessary files. There's a lot of different things that can happen with software related problems. And if it's not a Windows based software that comes with Windows, then a lot of times you're going to be working with the software vendor to try to figure out what the issue is. But a failed process may generate a memory leak or become a rogue process. You identify and remove using Task Manager. So the failed process may log an event to the application event log or the event log for the particular server role or software component. So you may see that. And that's why, again, I said it's important to look in the event log. Usually that's the first place I go to try to find an issue if there's something going on, to see if there's any logs being generated that would indicate an error or some kind of information. But that's generally where I go first. So then you have operating system related problems. So many of you probably had a blue screen in Windows before, but the operating system may crash or not boot successfully. Possible causes for that are system file corruption, incorrect device driver, or configuration change in the Windows registry. So if the system crashes, you want to ensure that the latest critical updates for software are on the system, and then examine the system event log in the event viewer at the time of the system crash and see what the errors are. System boot failure following a crash, you want to access the advanced boot options menu. And then you must enable the advanced boot options menu. When the Windows Boot Manager screen opens, you press the F8 key to access the advanced boot options menu. And this is what that looks like. And you press F8 here. And then you get your safe mode, all this last known good configuration, all those type of things that you can go into. So here's kind of all of the options that you see on the advanced boot mode. I'm not going to go into each one, but these are all the ones that are listed there. It shows you what exactly each one does. Most common one is safe mode, and then safe mode with networking. That basically loads it without a lot of the drivers and extra services to see if it will boot that way. Another one that's commonly used is last known good configuration. You can use that as well. So network related problems. So network connectivity issues are generally, they're probably the hardest thing to diagnose, especially on the Windows side. A lot of times you have to involve your switching and or upstream networking devices to try to figure this out when there's a network related problem. Unless it's something with a network card where it doesn't work at all, then you would know that's the issue. So unable to connect to other computers on the network from a Windows 2019 system. So what's your test strategy? So you check your network interface for valid IP configuration. Then you run your IP config/all, which will show you that. You ensure that the DHCP server is available on the network and has not exhausted its range of IP addresses. That only applies if you're using DHCP. If you're not using DHCP for this server, then obviously that would not apply. So you can test connectivity to the IP address of your network interface. So if you ping the IP address, you can do that in a command prompt. Optionally, in Windows PowerShell, you can do test-net connection with the IP address. That'll do the same thing. And then you can test connectivity to an IP address on the same LAN as the network interface you're using. So you either use the ping or test network connection for that. So that's kind of your hierarchy. You test pinging the local IP address, then you test pinging an address on the same LAN, which usually will work if there's network connectivity. And then your third option would be to test connectivity to an IP address on another LAN or a public IP address on the internet using ping. So if you can ping on the same LAN but not on another LAN, that indicates an issue on the network with routing. So that is where you would have to go in and leave this Windows device and go and troubleshoot that on the networking switch side or router or whatever it's connected to. If you're unable to contact computers outside of your LAN, as I just said, it may have an incorrect default gateway configured on your network interface. The router between your computer and the target IP address has failed, contains incorrect configuration, or is experiencing high load. And then you supply the target IP address as an argument to the tracert or trace route command to determine which router is the source of the problem. Trace route's a great command, however, sometimes it doesn't really help too much. Especially when you know where the problem is, it doesn't help a whole lot. But you can use it to try to isolate what, if you have a very complex network, you can try to use it to isolate what the problem is or which network device has the problem. So continued, if both the local and remote LANs are accessible from the system by IP address, the issue is likely due to name resolution, so a DNS problem. So you test connectivity to the fully qualified domain name of a computer on the network. So you do like ping space and then, whatever your computer is, .TEC330.local. If that fails, ensure that your network interface lists the correct DNS server for name resolution and that the DNS server is available on the network. If the DNS server is unavailable, then specify an alternate DNS server in the network configuration, and that should fix the problem for you. So service access issues. Clients are unable to contact a particular service running on the server from across the network. So how do we test this? So we use Task Manager to determine if the network service is running. If it's not running, we start it. If the network service fails to start, we check the associated system event log for the system event log. So continued here. So we determine if the service is listening on the correct port. This is an important command to try to troubleshoot service issues. So netstat space -a will show you all of the ports that the server is listening on. So if the network service is configured to listen on a non-standard port number, client programs need to specify the non-standard port number for a connection to be successful. So again, if you do the netstat -a, that will give you a list to make you, to ensure that it is listening on that specific port. So continued, we see if the service is responding to requests on the correct port number. If the network service is responding to requests, attempt to access the network service from the local computer using an appropriate client program. So if that works, you attempt to access the service from another computer on the network by connecting to the service by IP address. If you are able to access the service locally but unable to access from across the network, then there is some kind of firewall or network rule that is likely preventing the access. So to fix that, a lot of times that's an upstream problem. So you'll have to make changes on your firewall or your network switch, whatever is in between them that would be preventing that via ACLs or firewall rules. So if you attempt to access the service from another computer on the network by connecting to the service using fully qualified domain name, if you can access the service from another computer by IP address but not domain name, then name resolution is the issue. Ensure that, and then we go back to the same issue, ensure that the fully qualified domain name exists in DNS first, and then also ensure that the computer that is hosting the service has the correct DNS server as well as the client. And And then you may need to clear the DNS cache on both the server and the resolver if you had to make changes, like if it was pointed to the wrong IP address or something like that. So most problems preventing clients from accessing services on a server caused by incorrect resource records in a DNS zone file or DNS cache. So reflected by posts on a website and social media sites. And then here's a funny little, image here. It's not DNS. There's no way it's DNS. It was DNS. So a lot of times DNS is the problem. There's some kind of misconfiguration in there, or it's having an issue or something like that. So a lot of times that is the issue. So network latency issues. Properly configured network requires lots of time for services to respond, and network requests or users receive occasional timeout errors when connecting to a service. The network may be saturated with traffic or has a limited bandwidth. So you want to examine the traffic using a third-party packet sniffer program. A lot of times you use Wireshark if you guys are familiar with that. That's a good one. And then to test network latency, you can do path ping and then the IP address, or you can do test-network connection / information level detailed for an IP address under PowerShell. Other network latency causes are firewall devices restricting network throughput or malfunctioning network interface, switch or router dropping IP packets. So first step is always to reboot the affected device, see if that fixes it. Then you move on to if it's a patch that needs in there, is it some kind of vulnerability or bug in the switch software, router software, could be anything like that. Network latency affecting a single computer, usually caused by an application on the computer. So use Resource Monitor to list the top processing, or Task Manager accessing the network to help identify application causing the problem. So first thing is trying to isolate the problem and then move on to trying to fix it. So in summary, this is just a brief way to go through and monitor and perform maintenance to maintain system integrity. Task Manager analyzes system performance and stops rogue processes. Resource Monitor displays specific hardware resources used by processes. Event logs store a detailed record of system and application notifications. And then these are viewed in the Event Viewer or Reliability Monitor. And then different troubleshooting procedures are used to solve different problems, as you saw there. It's a lot of if then, if that, do this, do that. So as you move on in your careers and get more experience troubleshooting, it becomes a lot easier to try to isolate problems and know where to go next. But that's it for this week and for this course. Don't forget to take your final. There is no lab or discussion board this week. So you'll want to take your final by Friday, December 22nd at 12 p.m. That's when it's due. And then everyone have a great holiday, and thanks for attending this course.